Welcome to the lecture on residual stresses in welding. So, in this lecture we are going to discuss about the formation of residual stresses which are generated during the welding process. As we know that during the fusion welding process the temperature is reached to a very high level, and from there you have further a very fast cooling rate because of the presence of metal all around, because when we are doing the fusion welding of metallic plates, so you have on both the sides you have metallic plates, and then you are also doing the welding by using the filler metal. So, in the weld metal zone you have formation of weld metal pool. So, that is in liquid state. So, certainly you are increasing the temperature by a certain heat source. Now, once the temperature is reached to the fusion point or the melting point more than that, so they melt the localized area, and after that they are cooling. So, for cooling that is very small quantity of weld metal in the pool, and the cooling is done very fast because it is exposed to atmosphere as well as on the sides they have the metal in contact. So, there is fast cooling. So, because of that and also there are a lot of other parameters, there are other constraints. So, because of the larger cooling rate, because of the other constraints like restraint because of certain type of members or so. So, the stresses are developed, and these stresses are locked inside the material. So, they are basically known as the residual stresses. So, residual stresses are the stresses which remain within a structure when all loads or reactions are removed. Means that when we do the welding, then once we are removing the welded specimen, then as it is there when it is removed from all the reactions or all the support or so, then the stresses which are still remaining inside the body, that is known as residual stresses. So, the traits of these residual stresses are that they must be self balanced within the structure. So, structure is there and you have the stress values, it may be different at different points, which are generated at different points, maybe because of the different varying cooling conditions or different conditions. So, but then they are all self balanced within the structure, and the structure is as it is. So, as we have supplied energy into the body, so that represents the presence of residual stresses, they represent storage of energy within the body, and they are elastic in nature. So, being elastic in nature, they can be released by the operations which release the elastic deformations with consequent dissipation of elastic potential energy stored in the material. So, you have different type of methods by which you can release these stresses, but then that further may lead to formation of a different set of residual stresses. So, you can do, suppose the heat treatment we can do for removing the residual stresses. Sometimes we can apply the stresses of forces also to remove the stress, maybe or we may use the application of heat to remove the residual stress in certain part. So, this way we can control this residual stress or diminish the value of the residual stresses, but then all these methods may also further generate the residual stresses in some other sense. So, this way the residual stresses are there in the material. Now, when we talk about the residual stresses, then they can be classified depending upon what is the magnitude or on what scale we are viewing that. So, we can view them as either macro stresses or micro stresses. So, as the name indicates, macro stresses means they are developed by inhomogeneous plastic deformation from external loading or non-uniform heating or by varied chemical diffusion. So, basically when we talk about macro means maybe on the larger scale. So, when we talk about the larger scale, not confined to the one grain or so very small places, when we talk on a larger scale, then it is macro scale. So, basically when we do the plastic deformation, when there is plastic deformation, even during the welding also we have this phenomena. So, because we are heating and then ultimately the plastic deformation also takes place, and then they are further cooling. So, all that. So, because of that, or you have non-uniform heating, or maybe you have also the chemical diffusion which is varied at different positions. So, all these basically develop certain type of stress in a macro zone. So, it is basically evaluated for many grains altogether in a certain very large number of grains altogether, and you are basically evaluating the value of stresses. So, that is known as macro stresses. So, just like you have the in a hoop. So, if you find that from a bent wire, so the flexural stress which is developed, that is the example of the macro stresses. Now, these macro stresses, they can be measured by the relaxation techniques. So, we use the strain gauges, and then depending upon the strain which is being experienced by the strain gauges, we find the value of stresses. So, being elastic in nature, you can find the value of the stress which is logged in. So, that way we can find these stresses. Next is the micro stresses. So, micro stresses are developed due to the heterogeneities and due to differences in elastic modulus. So, you have if you look at the material, it is polycrystalline in nature. So, every phase or every part of the material does not have the same property. So, you have the difference in the properties from point to point, and that is why you have the heterogeneity, and it may be due to the difference in the elastic modulus, because if you have two different materials or two different phases, you have the different elastic modulus of the two. Similarly, the two will have a different coefficient of expansion, like if you have suppose austenite and ferrite, or austenite, martensite and all that, or conversion from one to other. So, they have the different properties, and because of that the stresses which develop, so that is known as the micro stresses. So, as we discussed that normally in the case of polycrystalline materials, so because of the non-isotropic behavior of the crystalline grains in course of heating or straining or chemical change, these type of stresses may develop, that is micro stresses. So, normally these stresses are logged within a grain. So, that is why they are known as micro stresses, because they are measured for typically for one grain or two grain or so on the grain basis. So, that is why they are known as micro stresses. Typically we have basically two kinds of stresses we have developed, that is macro stresses and macro stresses. Macro stresses will be because of the inhomogeneous plastic deformation, and macro stresses will be because of this. Mainly macro stresses result in because of the transformation of phases from one to other during the as in the case of welding, you have the transformation of phase from liquid to solid. So, you have because of the formation of transformational products, you have the formation of these micro stresses. Coming to the residual stresses in the weld. So, when we talk about the welding, the residual stresses are developed or they arise due to differential heating of the plates by weld heat source. So, you have a heat source, and because of the differential heating of the plates, they result and because of that they result into a non-uniform plastic deformation and cooling also. So, non-uniform plastic deformation and cooling is there, that is the reason because of which there is differential heating, and then that is why these residual stresses are developed. So, now when the residual stresses are developed, they are developed because of the following reasons. One is hindered contraction and expansion of heated metal. So, many a times what happens that you are heating in a localized area, and it will try to, so once it is heated, then it will try to expand. So, for example, if you look at the members, so suppose you have two members, and this is the portion where you are doing the welding. So, these are plate 1 and this is plate 2, and here you are doing the welding, suppose. So, this is the welding. Now, what happens that when you are welding this, when the heat source is in this, you are heating in this region, and this is the heat source. So, what happens, this zone is becoming heated, and once becoming heated, it will try to expand. So, it will be experiencing a type of so it will be expanding, it will try to expand on both the sides. Now, these plates are basically cooler as compared to this zone. So, it will try to restrain it from heating. So, this region will try to expand this region, and this region will try to contract this region. So, a type of, so because of the the resistance which is offered by one by each other. So, this is trying to expand and it is trying to restrain it. So, it will be experiencing a type of compressive stress. Similarly, this will be and this will be subjected to a type of tensile stress, because once it is heating, then it will try to expand it. So, you have this plate will be subjected to some kind of tensile stresses, and this middle portion which is the heated one, it will be subjected to the compressive stress during the heating cycle. Now, suppose you are cooling. So, once you are heating, during that process that kind of the variation of stress occurs. Now, when it is cooling, at that time this portion will, so this is during the heating stage. Now, when it is cooling, the trend is opposite. When you are cooling, at that time this will be trying to contract, because the temperature falls very rapidly, and because of its temperature, high temperature, these are all heated now. Now, the thing is that it tries to get contracted, and this being heated, this will try to oppose it. So, there will be a tensile type of stress which will be subjected. So, this portion will be subjected to a tensile type of stress, and this portion will be subjected to a compressive type of stress. So, this way the you have hindered contraction and expansion of the heated metal, and this way the stresses are developed. So, that is what the concept of the hindering of the contraction or expansion. So, one of the element is trying to expand, another is trying to contract. So, you will have the formation of the stresses, and the stresses may be of varying nature, it may be tensile or it may be compressive. So, that is, so the formation of such type of stresses, they are known as mechanical stresses. Then you have the phase transformation. Now, what happens that during the phase transformation, when the different phases are formed, then you have, suppose in the case of steel based castings or so, medium carbon steel or so, when there will be transformation from austenite. So, when there is allotropic transformation taking place, when austenite will be transforming to ferrite and cementite, or austenite will be transforming to martensite. So, in those cases there will be because they have the different properties. So, because of that, and also there as we know that it have different C by A ratio, or they have different crystal structure or so. So, because of that, when they are transformed, as we know that because of the transformation from austenite to martensite, you have a lot of stresses are developed, and these stresses only are the reasons of very high strength of the martensitic phase, but then the stresses which are developed, they are known as metallurgical stresses. So, these residual stresses, it is not necessary that every time they are non desirable. So, they may be desirable also, but then suppose if you take the example of metallurgical stresses, then in certain cases it may be beneficial and in certain cases it may be not. If the stresses level are too high, in that case it may be it may not be the beneficial one. So, such type of stresses which are formed because of the phase transformation, they are known as the metallurgical stresses. Then comes another type of stress which are developed is the reaction stresses. So, what happens that many a times when we are welding, suppose we are welding, you have some type of structure where we have the two ends, and this is we are doing the welding here. If you are doing the welding here, now once you are doing the welding, the stresses are developed into this, and it will try to expand or contract depending upon the temperature conditions or the cooling conditions. Now, since it has restraint from the sides, it cannot freely move to any place, because it is either fixed at these ends, or in whatever way they may be having a certain kind of joint. So, in that case, since they are not free to move, and since there is expansion or contraction taking place because of the change in the temperature, because once you have the welding going on, it will be leading to increase in temperature. So, once they are trying to expand or contract and there is restraint from the sides, then that will lead to the formation of stresses inside the body, and this is because of this restraining action, and such stresses, when they are generated, they are known as reaction stresses. So, you have basically the mechanical stresses, metallurgical stresses, and also the reaction stresses which are formed in this. These are the three types of stresses. Now, let us discuss about the effect of these thermal stresses. So, the thermal stresses once developed, they can cause distortion of the workpieces when welded. So, when you are doing the welding, at that time, because of the development of these thermal stresses, because of the temperature at which it is subjected to, at the large temperature which it is subjected to, that can lead to the formation of residual stress, and because of that even the material can be distorted, it can be out of its shape. So, if the residual stress level becomes of larger value, then that may distort the material. That can cause also the distortion of welded object during machining. Many a times what happens that when you are taking the welded material out and when you are doing the machining, so in that case the stresses may be released from certain point, and maybe because of that, because we know that it is it has to be self balanced in itself. So, many a times we can see that because of the imbalancement of stresses or because of the improper value of stresses at different points, it may so happen that there may be the distortion of these welded objects during the machining process itself. So, that that job may be out of its shape. Because of the temperature, because of the formation of different type of undesirable constituents at inappropriate places inside the grain, there may also be the problem of stress corrosion cracking. So, in that case you may have the cracking developed, and mostly what happens that affects the type of fracture it is subjected to many a times. So, it may a ductile fracture in normal case may convert to a brittle fracture type of mode. So, that is there in the case of the formation of these thermal stresses. It may also adversely affect the ductility, fatigue strength and creep strength. So, basically they decrease the value of these ductility or fatigue strength or creep strength. Coming to the different kind of residual stresses which are formed, and then how their distortion is produced. If you look at, so as we see that you have in a butt joint weld, you can have the stress formation, and then further you may have the distortion in this. So, this is the longitudinal stress. Similarly, so that is denoted by L, and the T denotes the transverse stresses. So, transverse direction it is. So, when you have stress formation in that direction, when we talk about this is longitudinal stress and this is the transverse stress, and because of that you can see that you may have the shape getting out of the normal one. So, this could have been flatter one and it becomes something like the bowing one. So, that is in the butt joint weld typically it is seen. Similarly, if you look at in a T joint weld, here also you have the formation of the longitudinal stress as well as the transverse stress, and because of that you can see that how its shape is distorted. So, that leads to the distortion in a T joint weld. So, this is because of the formation of these residual stresses. Now, what we discussed earlier, that when we see that how this longitudinal and transverse stresses basically vary. So, what you see is, if you look at this figure, what you see is that as we discussed that in this case while heating this will expand and this will be subjected to the tensile, and it will try to stop the expansion. So, it will be subjected to compressive force, while when it cools finally. So, because finally it has to cool and come to the original temperature. So, while cooling it will try to expand, and this portion will try so to put a restraint on that. So, basically this will be subjected to a tensile type of stress. So, that is why you see that in this middle portion, if you look at in this middle portion, you will have the this tensile stress. So, this region if you look at, so that is why if you look at this, what you see is that you get such kind of distribution. So, that is what it is seen, that in the middle portion when you are talking about this longitudinal side, we are looking at this section. In that section, this portion is subjected to the compressive stress, because in the end it tries to be remaining in the expanded state, and this is trying to contract it. So, this is basically leads to development of a compressive type of stress in this region. Similarly, this region tries to get contracted, and these two regions try to get it pulling. So, you have tensile type of stress is developed, and that is why in this zone you have the development of the tensile stress, and that is how it goes. Now, if you look at the transverse one, if you look at this section, so in this section you have such kind of, so you have tensile in the middle, and here you will have the reaction stresses, and then you have tension in this portion. So, this way you have tension as well as compression stresses which are developed in the case of in the case of this transverse. So, transverse stresses are developed, and its distribution is like this one. So, this way and we have to be careful that these stresses value should not reach larger than the yield point. So, basically when these values reach then more than the yield point of the material, that may lead to some kind of deformation, plastic deformation or so. So, that is what you have to be aware of. Now, the thing is that you have certain methods of the measurement of such residual stresses. So, you need to know the different methods of measuring the residual stresses, and the residual stresses are measured based on three important techniques are there. There are although few more, but these are the three important methods: brittle coat method, photo stress method, and strain gauge method. And mostly strain gauge method is the most popular among them, where we use the strain gauge or rosettes to find the stress value. So, the concept is that when you have a specimen and you feel that it has the residual stresses in the specimen, then you have to locate that region where you have to find the residual stresses, and you try to relax this material by doing certain technique. So, that is strain relaxation. So, what you do is by you normally drill at that point a hole. So, once you drill the hole, the stress will be relaxed. So, stress will be released, and in fact what happens that will lead to the change in the strain. Suppose at this point you are doing the drilling. So, the strain gauges or rosettes which are there at different points, that may lead to, that may have there may be some displacement in them, or there will be some strain because the stress being released. So, that may lead to those value of strains at these points. Now, these strains at those different points, that may be calculated, that may be measured using the strain gauges, and then using the, so depending upon the in what you are doing the biaxial or uniaxial or triaxial state. So, you can find further, you can find from there using the property of elasticity, you can have the calculation of a stress value at this point. So, that is the main concept of measuring the residual stresses. Now, in that you have the brittle coat method. So, in the brittle coat method you are basically having a brittle coat on the surface, and we also apply you apply polish with aluminum, so that surface is quite shiny, and then when the drilling is done, and in that case there will be cracks developed. So, when the residual stresses are released, the cracks develop because of the brittle coat which is there on the surface. So, and these cracks which are also developed, normally the cracks also have certain say, they show that from where the crack is developing. So, in this case certainly where you are drilling, from there you will see that the cracks are developed. So, in that case and depending upon the position of the how these cracks are developing, and you have a calibrated CTs there. So, based on that you can have the calculation of the residual stresses by comparing the results of the stress coat on job with that of the calibration strip. So, that is done in the case of these brittle coat method, and then you have similarly you have the photo stress method, where so in the case of photo stress method you have basically the use of photoelasticity, which is there in that case, and in this case photo stresses are acting as basically the infinite number of strain gauges, which are practically of 0 gauge length, and then they are uniformly distributed over the surface. So, you have this on the surface of the welded object, and they are applied on the coated surface, that is aluminum sprayed surface, and they will be polymerizing first on that, and then again in that case also the hole will be drilled, and the strains will be relaxed. So, stresses once relaxed, so from the removed material, that will affect the photo stress coating. So, again there will be effect on the photo stress coating, and it will be becoming the so there will be basically refracting, because once there will be cracks, there will be refracting, and that basically you will have the plane polarized light. So, that will affect this photo stress material, and then you can further that will be changed into the two components that will be mutually perpendicular rays, and then in the direction of stress you can calculate the stresses. So, that you can further study, and you can have more idea about the these methods. Another method is the strain gauge method, where you have the surface, again you have the drilling at one point, and you have formation of strain receipts or strain gauges at the points, and then the value of strain will be calculated after drilling, and based on that you can have the calculation of the stresses. So, this way you can calculate these residual stresses from the specimen. Thank you very much.